So now we have exercise 6.3. In exercise 6.2 we have already discussed solution of inequalities in two variables, and they're everywhere in previous exercise, that is in 6.2 you had only one inequality. Now in this exercise 6.3 we may have number of inequalities. Before I get into first question of 6.3, let me see what this exercise 6.2 asked us to do. So for example, here in this Cartesian plane, suppose one inequality is this, which has this solution set. For example, this is a solution set of one inequality. You know how to find this. Suppose let's take one more inequality like this. For example, its solution set is this lower half plane like this. Now for these two inequalities here, if you look at a common region, the common region will be this one and this side. Okay, now I'll take one more inequality like this. For example, let's take one more inequality. This is third inequality. For example, this one. This is the third inequality, which has solution set like this, upper half portion. This is the solution of the third inequality. So among these three, which is the common region? The common region is the upper part of this this red line, that is this, lower part of the green side, that is this, and the upper part of the pink side, that is this. So this triangle is the common region. This triangle is called the solution of the given three inequalities. What do you mean by solution of these three inequalities? From this portion, if you take any point, then it would satisfy first, second and third, all the three inequalities, remember. So this common of all the three inequalities is known as a solution sets. That's what we want to do in the next exercise 6.3. Okay, we find the solution set of each given inequality and then we draw the common region. We show the common region. What we'll do, first we find solution of each inequality, that is exercise 6.2. that's what we did. For each inequality we do this, and then we show the common region. We show the common of all inequalities. We show the common region of all solutions or inequality. Common region of all the solutions. That's what we want to do everywhere. These are the two steps. Step number 1 is exercise 6.2, and step number 2 is find the common region. That much only. Okay, so let's go the first question. So we'll start with the first question here. So in the first question you are given, you can see there are two inequalities in the first question. Question number 1, x greater than or equal to 3, y greater than or equal to 2. Now we are doing exercise 6.2 for both of these inequalities. We find the solution for this, and we'll take the common. So for first, x greater than or equal to 3. So you know what is to be done. So we draw the table for this first, x and y. You can here consider equals to, just to prepare this table. X is 3, y is not there, y can be anything, I'll take 0. X is 4, y can be anything, I'll take 1. Just here x is fixed, remember. x is 3, I'm sorry, x is 3, y can be anything, x is 3, y can be anything, I'll take 0. 2, so minimum you need 2 points, I've just shown here 3, this 1. Okay, and similarly here for the second one, for y greater than or equal to 2 here, so you can just imagine y equals to 2. Now we prepare the table here. X can be anything, I'll take 0. Y is always 2. X can be anything, I'll take 1. Y is 2. We need just 2 points to draw a straight line. Now we represent this inequality as we did in 6.2, and we try to find the common region. Okay. So here, let me show first x-axis here. You know, this is origin, this is like 1, 2, 3 as we did. This is minus 1, minus 2, minus 3. Here 1, 2, 3, you know, minus 1, minus 2, minus 3. This much we know as we did earlier. Now, for this one, 3, 0, so somewhere here. 3 from x-axis and 0 from y-axis. 3, 0. Then we have 3, 1. This is 3, 0. Then 3 from here and 1 from here. That is this one. So we'll get the line through these 2 points. So I'm showing a straight line. This is the line. Okay. Which line? X equals to which line? X equals to 3 here. Okay. Now whether the solution set is this side or this side, that we need to decide as we did in 6.2. So what's the inequality here? X is greater than or equal to 3. X का value 3 या 3 से more होना चाहिए. So this side, the x should be greater than or equal to 3. So this side x is more, remember. So this is your required solution, right side. I'll just show 1 or 2 dotted points here. I'll show some dots here, remember. I'll show some dots here. No need to shed the entire region because we are not interested in this region. We are interested in common region. So I'll just show some dots on this side. This is the required region. Okay. Now we'll draw the another line. That is y equals to 2 or y is greater than or equal to 2. 0, 2. 0, 2 is somewhere here. 0 from here, 2 from here. Then 1, 2. So 1 from here, 2 from here. So we'll get the line through these 2 points. So this is the line, you know. This is which line? Here line is y equals to 2. Okay. Now which is the solution set, this part or this part, that we are going to decide. Y should be greater than or equal to 2. So y का value 2 या 2 से ज़्यादा होना चाहिए. So ये वाला region. So now tell me what's the common. In the previous one you had this region. This was the region. Now you have this region. So which is your required region? This much. This one is the required region. Shaded region. So every point from this one and so on. Every point from this shaded region would satisfy both the inequality. This is known as the solution of system of inequalities graphically. We are solving graphically, remember. So this is the solution of the given two inequalities. It's a combination of 2 or more questions from the previous exercise, remember. Okay, one more thing we'll see in straight line also here. directly you can write which variable is absent, variable y. So this must be line parallel to y-axis through 3. This is sometimes called, vertical line here. This is known as vertical line. Vertical line. And this is called, here, horizontal line. This is just for your information, horizontal line. How do we draw this? Which variable is absent here? Y. Y is absent here. Y is absent here. So this must be parallel to y-axis through 3. That's what we did here. Which variable is absent here? X. X is absent here. So this must be here, this one must be line parallel to x-axis through 2. That's what you have. Right? This just for information. The important one is this region for us. Okay. Question number 2 here, second question. 3x plus 2y is less than or equal to 12. We have 3 inequalities. X greater than or equal to 1. This is which line? This y variable is absent, so parallel to y-axis. So this is vertical line. Y is greater than or equal to 2. Which variable is absent? X. So this is parallel to x-axis through 2. So this is horizontal line. Right. The first one is neither horizontal nor vertical. So for first one, just to prepare the table, I'll take equals to 12 here. This is just for, to draw the line. Now we prepare the table here, x and y. If x is 0, what is y? 6. Let me take y equals to 0. So what is x here? If I put y equals to 0, x would be 12 by 3, which is 4. So you got 2 points. So done, finished. We just need 2 points to represent this line. Okay. What about this? X equals to 1. I'll now write it is a line parallel to y-axis. Why y-axis? Because y variable is absent through 1. Okay. And what about the last one? Here for this one, y equals to 2. Which variable is absent? X. So is a line parallel to which axis? X-axis through 2 here, through 2. Okay, so we'll show this. We'll represent these 3 lines in the Cartesian plane. In each case we find the region and then we'll see which is the common region. Okay, so now I hope this is clear to you. I'll just put inside the box here. Okay, this is just to draw the lines, remember here, 3 lines. Okay. Now as we did earlier, we consider 3 coordinate axes here. So these are the 3 coordinate axes. We show some points here. So this is 0, this is 1, 2, 3, 4, 5, 6 here. This is -1, -2, -3. Here 1, 2, 3. This is -1, -2, and so on. Okay. Now you know that this is x-axis here. This is y-axis. The first one 0, 6. So from x 0, from y 6, 0, 6. So here 4, 5 and 6 somewhere here. 1, 2, 3. Okay. and 4 comma 0. So from x4 y 0, x4 y 0, this one. So this is a line, and I'm showing that line here. So line would be this. Here, this is the line. Then what we do? We decide the region here. Which region? The solution set is this part or this part that we want to decide. What we do in such questions? We take origin normally. We take origin 0, 0. And we check whether it satisfies this inequality or not. So if I take 0, 0 here, 0, 0 if I take, and if I put into the first inequality, 0 plus 0 less than or equal to 12. So it satisfies this inequality. Okay. That means this point satisfies this inequality. So this is the required region. So I'll just put 2, 3 dots that this is the required region. Fine. Now we go to the second one. You know second one. What's the second one? It's a line parallel to y-axis through 1. Parallel to y-axis through 1. So this is our line. This is the line. This is called vertical line. Now you have realized. This is which line? X equals to 1. Okay. Now which region? This region or this region? That we are going to decide. What this inequality says, x का value 1 या 1 से ज़्यादा होना चाहिए. That is this side. यहाँ पे a1 x का value 1 से ज़्यादा है. So a वाला portion आया. A लाइन बोल रही थी लोअर पोर्शन, ए लाइन बोल रही है राइट साइड पोर्शन. तो अभी तक इतना कॉमन हो गया. देखो, दिस इज द कॉमन. अभी तक दिस लाइन से इज लोअर पोर्शन, दिस लाइन से इज राइट साइड पोर्शन. सो इतना ये डॉटेड जो दिख रहा है वो कॉमन है अभी तक. नाउ विल गो टू द थर्ड इनइक्वालिटी. व्हाट अबाउट द थर्ड इनइक्वालिटी? थर्ड इज y equals to 2. That is line parallel to x-axis through 2. Parallel to x-axis through 2. So this is the line. Okay. This is which line? Y equals to 2. Now you decide the region on based on this. Y का value 2 या 2 से ज़्यादा होना चाहिए. That is ऊपर वाला portion. This says lower portion, this said this portion, this said above portion. So which is the common region? This much. Actually ये पूरा है, remember. But ये तीनों का common इतना ही है. So ये जो छोटा सा triangle आप देख रहे हैं, this smaller triangle is the solution of all the inequalities. So every point from this inequality satisfy the given three inequalities. Every point from this portion would satisfy all the three inequalities. Right? आपको इतना बताना है. Common of all the inequalities. Question number 4 here, fourth question. Third you can try because there are just two inequalities. Here also we have two. X plus y is greater than or equal to 4. And the other one is 2x minus y is less than 0. Here we have strict inequality. Here you have greater than or equal to, here you have less than. Okay. So first we just to draw this, we take x plus y equals to 4. I'll prepare the table here. If x is 0, what is y? 4. If x is 1, for example, what is y? 3. Any 2 points, remember. Any value of x you can choose and you can get the value of y. Or any value of y you can choose and you can get the value of x. Okay, so these are the 2 points. What about this? Here 2x minus y equals to 0. We prepare the table to draw a straight line. If x is 0, y is also 0. It passes through, you can say origin. Now let me take x equals to 1. So y would be 2. So one is 0, 0, the other one is 1, 2. Okay, so we just draw these two straight lines. We find the solutions of these two inequalities and we get the common region. That's what we want to do. Okay. So I'll just show two coordinates axis first, x-axis and y-axis. Origin here 1, 2, 3, 4. Here -1, -2. Here 1, 2, 3, 4. Here -1, -2. You know this because of these 4 quadrants. Now for first one 0, then 4. X is 0, y is 4. So this point. 1, then 3. 1 from here, 3 here. So we have this straight line. So I'll show it here. Okay. So the straight line would look like this. This is the first straight line. Now question is, which is the required region? This region or this region? This part or this part? For that what you do? You take origin normally. कोई भी point ले सकते, remember. Anything, any point from this region or this region. But for origin it's easy to verify, remember. So I'm taking origin. So take 0, 0 here. 0, 0. Check whether it satisfies the given inequality or not. 0 plus 0 is greater than or equal to 4. So this is not true. 0 plus 0 is not greater than or equal to 4. That means this is not the required region. So your upper part is the required region. Just I'll put 2, 3 dots. That this is our required region. This one. Fine. Will not show the entire shaded portion because we want the common region. This region is the required region. You take any point from this, it would satisfy this inequality. Okay. Now we go to the next drawing. This one 0, 0, that is origin. 1, 2, 1 from here, 2 from here. So we have the straight line like this. But here we have strict inequality, remember. So I'll just draw the dotted line. That is, the points on the lines are not included in the solution. Points on the line are not included in the solution. That's why we'll just show it by dotted line, because we have the strict inequality here, remember. Okay, now we decide whether it is this region or this region. Which is the region for this one? This right side region or this left hand side region? Okay, so take one point from this portion. Suppose I am going to choose this portion. Can you tell me coordinates of this portion? It is 2, 0. Here you cannot take origin because that line itself passes through origin, you can see. You cannot take this origin. Take 2, 0. Put into the inequality. 2 into 2 minus 0. That's 4 less than 0, less than 0. Is this possible? No, 4 is not less than 0. That means 2, 0 doesn't satisfy this inequality. Now from where you had chosen 2, 0? From here. That means this is not the required region. So where is the required region? This one. Okay. So this portion, left hand side portion. Here it was upper portion. So what's the required solution? This one is the required solution. This one. Up to this. This is the solutions of given two inequalities, remember. This portion. It's not finite. It's, infinite region. It's go on, remember. It would move like this. It would move like this here because lines are extended to infinity, You can extend the line like this. This represent the solutions, remember. Every point from this region would satisfy this as well as this, both inequalities, remember. Fine. I repeat again, for dotted line, it was this portion. For this line, it was upper region. So this is the required region, remember. Question number 5 here. The two inequalities, 2x minus y is strictly greater than 1. and x minus 2y is strictly less than minus 1. Okay, so first what we do, we prepare the table. So I'll imagine 2x minus y equals to 1. Here x, here y. If x is 0, what is y? Minus 1. If x is 1, for example, I'll put 1 here. So I suppose y would be, if I put 1 here, this is 2. So this will be 1, I think. So one is 0 comma minus 1, the other one is 1 comma 1. 1 comma 1 would satisfy that, remember. Okay. What about this? Here x minus 2y equals to minus 1. Again we prepare the table. So if x is 0 here, anything you can choose, remember. If I put x equals to 0, what is y? 1 by 2. It will do, remember, 0 comma 1 by 2. Let me take y equals to 0 here. What is x? Minus 1. So you have 2 points, 0 comma 1 by 2 and minus 1 comma 0. I repeat, 0 and minus 1, because if x is 0, y is minus 1. If x is 1, so 2 into 1, 2, take 1 on this side, y is also 1. If x is 0 here, y would be minus sign will get cancelled, just 1 by 2. And if x is minus 1, what is y here? Or if y is 0, x is minus 1. You need minimum 2 points. You can choose anything, remember. I have chosen this way. Okay. Now we'll just find the common ration. So let's take this x-axis. You use foot ruler. This y-axis here. This y-axis here. This is origin. Here you have 1, 2, 3 and so on. Here you have minus 1, minus 2, minus 3 and so on. Here you have 1, 2, 3, minus 1, minus 2, minus 3. Okay. Now what we do? First line 0, then minus 1. 0 from here, minus 1 from y-axis. 0 from here, minus 1 from here. 1, 1. Where is 1, 1? 1, 1 is here. Now we have strict inequality, remember. So we draw the dotted line. Here we consider the dotted line. The points on the lines are not included. That's why this is called the dotted line. Okay. Now which is the required region? This right side region or this left hand side region? So what you do? You can choose origin here because line doesn't pass through the origin. Check whether 0, 0 satisfy that inequality or not. I'll take 0, 0. I'll put into the first inequality. So 0 minus 0 is greater than 1. Is this possible? No. So from 0, 0, if I put into this equation, that is from this region, if I take 0, 0, if I put into this inequality, 0 greater than 1, not possible. So this is not the required region. So this right hand side is the required region. I'll just put 2, 3 dots that this is the required region. It means every point from this region would satisfy this inequality. You take any point. Suppose I have taken this point. What are the coordinates of this one? 2, 0. I'm just showing for your information. Put into this inequality. 2 into here. 2 into 2 minus 0. So 4, and 4 is greater than 1. So this is the required ratio. Okay. Now we go to the second inequality. Here you should write actually 2x minus y equals to 1. This is a graph of this straight line. Okay. Now we'll draw the second one. There 0 comma minus 0 comma 1 by 2. So 0 from x-axis, 1 by 2 from y-axis, this point. 0 and 1 by 2. Okay, then minus 1 comma 0. So minus 1 from x-axis, 0 from y-axis, this point. So you have a straight line, you have strict inequality. So again dotted line like this. Now question is, this is the required region or this is the required region? For that black, the first line we had this region, remember. Okay, that we keep in our mind. Now what about this? Again you take one point from the these two planes. So here you can take again origin because that's not on the line. I'm taking origin here. Okay, check whether origin satisfy the given inequality or not. So here 0 minus 0 less than minus 1. Is this true? Yes. 0, no, sorry, this is not true. 0 is not less than minus 1. 0 is not less than minus 1. So solution set is not the region which contains 0, 0. That is opposite region. So this is the region above the green line. What about the this line here? This portion. Here it is this portion. You see above the green line, this one. For dotted line it was this. For dotted line it was this. For green line it is this portion. So I think if you just notice, this is the required solution. The portion is this. You can just see here. This is the required solution. Please see this. This is the equation of, here green line is the equation of which inequality? X minus 2y equals to minus 1. I repeat. See, for this first one it was this portion. For second one it is this portion. So this is the required region. Here this side there is no common region, because here it is this side as well as the upper side. So this one is the required region. Every point from this region would satisfy both the inequalities, remember. And so on. It's like that circular cone, remember, here. Okay. Next I'll go to 10th question. See, there we have basically 4 inequalities. The first one is 3x plus 4y is less than or equal to 60. Next one is x plus 3y is less than or equal to 30. Then we have x greater than or equal to 0, y greater than or equal to 0. Now if you look at the last two inequalities, x is positive and y is also positive with 0. What's the meaning of this last two inequality? Basically it says that first quadrant, remember. You know, x and y both are positive, that means it would be which quadrant? First quadrant. So no need to draw the last two inequality. Getting me? Just you need to draw these two, find the common region in the first quadrant only, remember. Find the common region where? In the first quadrant. The same way you have the question number 13. Right? If you just refer the question number 13, there also you have first quadrant, last two inequalities. Question number 14 also, there the solution will be in the first quadrant. Look at it, last two inequalities. Y greater than or equal to 0, x greater than or equal to 0 in question number 14. So first quadrant. Question number 15, again last two inequality, first quadrant. So in this 4 questions, the solution set would be in which one? First quadrant, remember. Fine. Okay. So now what we do? We just find the common region of these two where? In the first quadrant. Okay. So here we just prepare the table. 3x plus 4y is equal to 60. X, y. If x is 0 here, what about y? Y would be 15. If y is 0, what about y is 0? Then x would be how much? 20. So 0, 15 and 20, 0. If x is 0, y is 15. And if y is 0, x will be here 60 by 3, which is 20. So these 2 points. Okay. What about this? X plus 3y equals to 30. So x is 0, y is 10, y is 0, x is 30. So we have such points 0, 10 and 30, 0. Now we draw these two straight lines and we just find the common region. Okay, so here first let me show y-axis here. Y-axis, you know it. Then we have x-axis here. This is x-axis. Now I'll choose the points. As you can see, we have 15, 20, 30. So I'll choose the points like this: 0, 5, 10, 15, then 20, then 25, then 30, and so on. Here -5, -10, here 5, 10, 15, then 20, then 25, 30, and so on. Here -5, -10, like this. Okay. Now for first one we have 0 and 15. 0 and 15. So 0 from here, 15 from here, 1 this. Then we have 20, then 0. So 20, then 0 here. Okay. Your interest is in the first quadrant, remember only. Keep that much in your mind. Okay. So we have this straight line. Now, which region? This region or this region? Now this is a straight line for which one? 3x plus 4y equals to 60. Okay. Now put 0, 0 here. 0, 0 is here in this region and the inequality. So I'm putting 0, 0 in the inequality. First inequality, 0 plus 0 is less than or equal to 60. This is true. That means this lower region. So this region. And it's in the first quadrant. So you are not going outside this, remember. Because the first, if you notice here, we already mentioned the beginning that region should be in the first quadrant. Okay. So here, this is the first quadrant. So we concentrate over here. You cannot show below this or this side because here you are restricted to first quadrant. Okay. Now for the second inequality, 0 then 10. 0 from here, 10 here. 0 then 10. 30 then 0. 0 then 10 and 30 then 0 here. This portion. So I'll draw a line again from these 2 points. So this is the line here. This is for which line? That is x plus 3y equals to 30. Okay. Now for this line, question is above this black line or below this. So again what I'll do, I'll check for origin. 0, 0. 0, 0 is here. I'll put into the second inequality. 0 plus 0 is less than or equal to 30, which is true. That means the region containing 0, 0 is the solution. So below this dotted line, that is this one, but this lower this red line and in the first quadrant. So this is the solution set, this portion, remember. Common of both. For this red line it is this side, for black line it is this side. So this is not common, remember, only this much. This polygon you can see. This one, this one, this one, and up to this portion. This is the solution set, remember. It satisfies all inequalities. It is in the first quadrant. It satisfies first as well as the second. So this is the required solution.